Hi everyone, this is coming to you from Education for All. We are looking at introduction to loci on an Argand diagram. Introduction to loci, some say loci, locus more or less of point. So what is a locus? Something you must have come across, might not be new to you. A locus is the path traced out by a point that satisfies certain conditions. That is the definition of a locus. On an Argand diagram, the locus is a set of all complex numbers z that meets a given equation or inequality. On an Argand diagram, that is how we define a locus. So, why do we need to study this topic, introduction, loci on an Argand diagram? Why do we need to study a topic like this? There are a couple of reasons, but we'll outline just two reasons here, which are very important. One, loci on an Argand diagram, they help us to connect algebra with geometry in the complex plane. Because what you display, you are given an equation, and you display that equation in an Argand diagram. So because you are transforming an equation into a diagram, that is, you are transforming algebra into geometry. So that is one benefit of doing this topic. The second point here I want to highlight is that they help us in understanding transformations like rotations. You are rotating an object on an Argand diagram. Translations, you know what translation is? You're moving the objects from one position to another position. And as well as reflections in the complex plane. This is the importance of studying this topic. So what types of loci on Argand diagram are we going to look at? We're going to look at three different types. We're going to look at circles. You know what a circle is? Something that is round. It's not perfect, but this is a circle with a radius, circumference, and all points here are equidistant to this center. From any point on the circumference, this is equal to this, and as well as this one. So each point here is x plus I, y. So let me just call it z x plus I, y, because we are dealing with complex numbers. So each point on this circumference is this equation, is this function. We shall look at this in depth. And then we'll look at half lines. What is a half line? You just say half lines. What is a half line? A half line, more or less, is a straight line that has a beginning but not an end. It extends to infinity. You have a coordinate system like this, and your half line might start from here keeps going non-stop. It's going in that direction, but it will have an angle here. I display an angle to the horizontal, to the positive x-axis. So in fact, let me make it this way. This is your x, this is your real axis, this is your imaginary axis. So display an angle here. So this line here that never stops, it's also called a half line. It makes an angle theta with the positive real axis. That's what we call an half line. When we solve problems, you will see proper use of these half lines. And again, the third one we're going to look at, perpendicular bisectors. So what is that, perpendicular bisector? Simply means if you have two lines, 2 points, we have done this even in primary school, finding a bisector. This is your Z2 here, this is your Z1 here, and you want to find points that are equidistant, that are equal between these 2 points. So that line will not be like this. It's wrong. You will find the midpoint between these two, and that line is perpendicular to these 2 points. So this line, any point here, is equidistant to these 2 points. So that's what we call by perpendicular bisector, because this line here is bisecting these 2 points. These 2 points. This line is bisecting these 2 points. And the one that satisfies the condition has to be the one that is perpendicular to these 2 lines. If you have one that goes like this, you know it's at an angle. It's not right. If it goes like this, again, it has an angle. It's not right. That angle here, which is not 90 degrees, so it won't be the perpendicular bisector of these 2 points. It has to be 90 degrees, so which is the one that goes through the middle of the 2 points. So that is the introduction of loci on an Argand diagram. So we are now going to look at the types. We have types, I mean these circles, half lines, perpendicular lines. We're going to solve problems on them step by step. We'll start with simple problems, intermediate, and then we'll go to advanced ones. Thank you for watching. Bye bye.